Hi, my name's David French, and I'm a Senior Security Research Engineer for Elastic Security. And in this presentation, I'm going to be talking about Dorothy, which is a free tool for security teams to test their visibility and detection capabilities for their Okta environment. So I had the idea to build Dorothy a few months ago after I was researching Okta's single sign-on solution and developing new rules to alert on suspicious behavior in Elastic Security. And what I found was I didn't have a way to test if our Okta rules were working other than logging into my Okta development environment and then making manual changes to trigger our detections one by one. And I found this method kind of cumbersome, time consuming. So what Dorothy does, it helps security teams execute these atomic tests in an Okta single sign-on environment to assess their visibility and detection coverage. And in this presentation, I'll show you how you can get started with Dorothy. I'll also show you how to get started with Elastic Security and our free detection rules. Here's what I'll be covering in this presentation. So I'll spend a couple of minutes explaining how Dorothy can help security teams with their monitoring and detection goals. I'll show what a typical workflow looks like when a security practitioner uses Dorothy. And for those who aren't that familiar with Okta, other than how to log in and access their apps, I'll give you a brief overview of Okta terms and how some of their components fit together. And you don't have to be an Elastic Security user to use Dorothy, but if you are an Elastic Security user, you can easily index Okta's system logs and enable our free detection rules to alert on suspicious behavior. And I'll demonstrate how to do those things too. And then I'll give a demo of how to use Dorothy and its various modules to execute actions in an Okta environment. And the link to these slides will be included in the description for this video so that you can access all of the resources that I've linked to throughout this presentation. Okay, so Dorothy was created to help defenders, not enable attackers. So it's important to note that this tool doesn't offer any modules or capabilities to obtain initial access to an Okta environment or to perform privilege escalation to gain more permissions than the API token already has. So to execute any actions using Dorothy, it needs an Okta API token that's linked to an administrator's user account. Offensive scripts and tools do exist on GitHub to perform attacks like password spraying against Okta environments, but these capabilities are out of scope for Dorothy. I've included a link on this slide for people who aren't familiar with some of these terms and would like to learn more. Dorothy has over 25 modules to execute actions in an Okta environment. All modules are mapped to the relevant MITRE ATT&CK tactics like persistence, defense evasion, or impact. And Dorothy is an open source tool. You can find it on GitHub and PyPI. So here are some of the challenges that security teams face with regards to doing detection engineering and testing their visibility and detection coverage. I'm using Okta's single sign-on solution as an example here. Imagine that you work in a security team and you want to make sure that your Okta environment is well monitored. So firstly, you have to learn all about Okta, how it's configured, how it's used in your organization, what's normal, what would be considered suspicious. You have to learn and examine Okta's logging schema. So what are the various field names and what do they mean? What events matter and which ones are just noise? You have to research how attackers are operating in Okta environments in the wild. So how have other organizations been breached via their Okta environment? If you can't find any open source intelligence on this, can you put yourself in an attacker's shoes and figure out how they might operate in an Okta environment after they have initial access? And then you have to develop detection rules to alert on suspicious behavior. And then finally, you have to regularly test your detections to make sure they're working or identify and remediate gaps. So many security teams are already oversubscribed and don't have the time to do all of this. If they're an Elastic Security user, we can take care of this for them with the exception of running tests in their organization. And that's where Dorothy comes into play. By the way, this isn't a problem specific to the Okta identity management solution. There are plenty of other solutions that are widely deployed but poorly monitored by security teams, if at all. So here's what a typical workflow looks like when a security practitioner uses Dorothy to test their Okta visibility and detection. So step one, the operator installs Dorothy and creates a configuration profile to connect to their Okta environment. They execute various actions in their Okta environment to simulate behavior that their security team should be able to see. And for step two, Okta's system log is like an audit trail that logs most activity that happens in an Okta single sign-on environment. Elastic has a fleet integration and a FileBeat module for Okta. These components ship the system logs to Elasticsearch. At step 3, Elastic Security detects and alerts on suspicious or notable behavior. At step 4, the analyst reviews the alerts in Elastic Security and verifies that the detections are working as expected. And again, the security team doesn't have to be an Elastic Security user to use Dorothy and get value from it. But if they are an Elastic Security user, they get to take advantage of the stuff on the right-hand side of this slide. So our protections team researches adversary tradecraft and develops detections and preventions to protect our users. Our detection rules are free and open, developed alongside the security community. And we have over 360 rules and 26 rules for Okta specifically. So before we dive in and look at how to install Dorothy and get started, I'll give you a brief overview of Okta's single sign-on solution. I won't spend too much time on this, but there are a few terms that you might not have come across before. So when we consider the benefits of Okta's single sign-on solution, administrators can tell their users that they only have to remember one password instead of many. And this gives administrators the opportunity to enforce stronger security controls like increased password complexity, and they can enforce things like multi-factor authentication. So many organizations have been breached due to password spraying attacks. If the attacker has harvested a list of usernames, they might try and log in as each user using a common password like winter 2021 until they get into one or more accounts. Many opportunistic attackers will move on and look for an easier target if they see multi-factor authentication enabled. So when we think about potential risks with single sign-on solutions, you can think of these systems as a type of skeleton key that give access to many apps and lots of data using a single account. So if an attacker compromises a single account, they could find themselves with access to a ton of information and systems. Many enterprises have centralized their identity and access management systems, but they're often poorly monitored for suspicious behavior. So if you're not familiar with Okta's single sign-on solution, here's a basic overview of the terms that they use and some other relevant information. So each component in an Okta environment is referred to as an object. So first up, we have users who log in to an Okta environment to access the apps that they've been given access to. Users are organized into groups. Permissions can be assigned to groups to decide what apps they get access to. Then we have roles that can be assigned to users or groups to give them administrator permissions in the Okta environment. Then we have apps that users access, so things like Google Workspace and Salesforce. Then we have various types of policies that are applied to apps and control things like authentication requirements. Okta network zones are used to allow or deny network traffic based on IP address ranges. And then Okta system log records most activity like users logging on, user lockout events, and configuration changes. So again, Dorothy needs a valid API token that's linked to an admin user's account in order to execute any modules. So here's an official diagram from Okta on the typical architecture for an enterprise. I've included this as a reference on this slide. And again, these slides will be shared in the description for this video. So now I'm going to show you how to install Dorothy. So as mentioned earlier, Dorothy is open source. You can find it on GitHub. You can also find it on PyPI. And this is how we're going to be installing Dorothy in this demo. We're going to start with an empty folder to install Dorothy. So we're going to create a Python virtual environment. You're going to need Python version 3.7 or above. So we're going to create a virtual environment first. That's done. Okay, and we're going to activate our virtual environment here. And then Dorothy has been uploaded to PyPI. So we're going to install Dorothy, pip install Dorothy. And then all of the dependencies will be installed automatically. Okay. And now we can simply start Dorothy by executing the command Dorothy. So when Dorothy starts up, it's going to look for a thing called a configuration profile, which is used to connect to an Okta environment. Because it's a fresh install, it's not going to find one, so we're going to go ahead and create one. So we're just going to call this my Okta environment. You can give that a more descriptive name. I'm just going to copy and paste the Okta URL for my development environment here. And if you don't have one, you can just go to Okta's website and sign up for a free developer account. And it's going to ask us for the API token that's linked to the Okta administrator account. And again, if you don't have this, it's pretty easy to set up. Once you've got your administrator user in Okta, you can just create a new API token. So I'm going to paste that in here, and the input will be hidden. And you have the option to store the API token in the local configuration file on your local host. I'm going to say yes, that's okay. A couple of things that are important to note. Every menu in Dorothy has got a help menu, and the commands have got tab auto-completion. And we'll execute our first few commands. So we can do list modules to review all of Dorothy's modules. Again, they're all mapped to the relevant MITRE ATT&CK tactics. And then you've got the module name and a description for what each module does. We're going to execute who am I to see which user this API token is linked to and what groups they're a member of. Okay, so we can see that this API token is linked to me, and we can see which user this API token is linked to, what roles they're assigned, when they last changed their password, that kind of useful information. I'll show you how to use Dorothy's modules in detail soon. We're going to come back to this, and now I'm going to show you how to set up our Elastic security environment and enable our Okta detection rules. So now we've got Dorothy installed and we're connected to our Okta environment. I'm going to show you how to index Okta's system logs in Elasticsearch. And these are the logs that our detection rules are going to look at to alert on suspicious behavior. So I spun up an Elastic Cloud cluster earlier. So this is Kibana. If we want to ingest Okta system logs, we can go down to Fleet. Fleet allows us to get data into Elastic Security easily. So if we go to integrations, and then we search for Okta, and we're going to click Add. And here's where we configure the Okta integration. We're going to be collecting logs from Okta's System Logs API. So in here, you're going to configure some settings. It's going to ask for the API key for your Okta environment and things like the URL for your system log. And in the slides, I'm going to include a link for the documentation on how to configure this. And we'll click Save, and we need to install this agent on a host for it to grab those system logs on a regular interval and then index those in Elasticsearch. For people who already use FileBeat in their environment, we have an Okta module for that. So similar to the Fleet integration, it's going to grab those logs from the Okta system log API on a regular interval and then ship those to Elasticsearch. So now we have our Okta system logs flowing into Elasticsearch. We can enable Elastic Security's Okta detection rules, and these are going to alert us to any suspicious activity that happens in our Okta environment. Okay, so in Kibana, I'm going to go into the security app. I'm going to go into detections. Okay, so in Kibana, I'm going to go into the security app. I'm going to go into detections. I'm going to go into manage detection rules. And I'm going to click this option to load all of Elastic's pre-built rules. We've loaded all of the pre-built rules, and we're going to go to tags, and we're going to filter the rules by Okta. Click on Okta, and we're going to select all of these rules, and under bulk actions, we're going to click on activate selected. And this is going to activate all of the Okta rules in this Elastic security environment. So let's review what we've done so far. We've installed Dorothy. We know we're connected to the Okta environment and can execute commands. We've configured Fleet to ship Okta's system logs to Elasticsearch. And we've enabled the Okta detection rules in Elastic Security to alert on suspicious behavior. Now let's look at using Dorothy to execute actions in an Okta environment. So let's think about some actions that an attacker might take in an Okta environment, and we'll execute Dorothy's modules to simulate those actions. So we're going to execute main to go back to the main menu. So first things first, let's execute some discovery actions to learn a bit more about the Okta environment that we have access to. So we're going to go into the discovery menu. We can hit help to see what modules we have available. So first, let's get users. So each module has a help menu to tell you what the module does. Most of the discovery modules you can just execute. You don't need to configure any additional options. So we're going to execute this module. It's going to ask us if we want to harvest all users. We're going to hit yes. And then once all users are harvested, it's going to ask us if we want to print the information. And then we can also save any harvested information to a file. So we could open up and review that. At this point, we're going to go back. We might want to get all applications in the Okta environment. And then we might want to get information on all configured network zones in the environment as well. So we've got 3 network zones to review. Just to review other discovery modules that are available, you've got find admins to find other Okta users with admin roles assigned, and you have a module to find users without multi-factor authentication enrolled. So let's think about how we might want to persist in the Okta environment. We could create a new user, we could assign an admin role to another user, and we could also reset another user's password. So we're going to go back to the main menu, and then we're going to go into the persistence menu. Let's start off by creating a new user. And if we execute info for this module, you can see that we need to set some options. Some of them are required, some of them are optional. So we're going to go ahead and enter the information to create a new user. So I'm going to paste this information in for the new user. And I'm going to type info again. So we can see we're going to try and create a new user called Joe Harding. We're going to leave out the group IDs for now. The user will be put into the everyone group, which is the default group of users. And we're going to execute the module. It's going to ask us to enter a password for the new user. Hit enter. And we see we've created a new user. So if we've written down that username and password, we've now got a user that we can log back in using if we lose access using this main account. So now we're going to try and reset the password for a user. If you remember, we harvested information on all users before. So we now have the ID of the user we want to reset the password for. So I'm going to type in reset password. And we can hit help for this module to see what it's going to do. And we can hit info to see what information is needed to run this module. So we just need an ID for a user. So I'm going to do set ID, enter the ID for the user, hit info again. That looks good. Let's execute this module. And it gives us a one-time link to reset this user's password. So I could go ahead and do that. Now we're going to make another user an admin. So we're going to go back to the persistence menu. We're going to create an admin user. We're going to hit info. We just need an ID again for a user. So we're going to choose a different user ID this time. Execute the module. Dorothy will ask us which role we want to assign to the admin. And we can create another super admin user here. So I'm going to choose option 9. And that admin role has been assigned to that user ID. So for that user we just assigned an admin role to, let's assume that they have multi-factor authentication enrolled and we want to remove that. We can do that. So we're going to go back to the persistence menu. We're going to type in reset factors. Check what options are required again. We just need a user ID. So we're going to enter the ID for the user and execute. And now we've removed all multi-factor authentication factors from this user. So now let's imagine we want to disable some Okta components or change them to weaken the target's security controls or cause some disruption. We're going to deactivate an Okta network zone and an applications policy. So we can go back to the main menu. We're going to go into the defense evasion menu this time. See what modules are at our disposal. We're going to go into change zone state this time. We're going to set the ID for the network zone we want to change. And we can execute this module. So it's going to grab the network zone. It's going to tell us the current status. It's active. It's going to ask us if we want to deactivate the zone. We can hit yes. That zone's now deactivated. And we can reactivate that zone if we want to. Just go ahead and do that. Okay, so now we're going to go back and now we're going to change a policy state this time. We're going to enter the ID for the policy we want to deactivate. We're going to hit execute. It's going to grab the policy and tell us its current status. It's going to ask us if we want to deactivate that policy. We're going to hit yes. So as you can see, Dorothy makes it easy to carry out actions in an Okta environment. Let's go back to Elastic Security and see if any of our detections generated any alerts. So back in Elastic Security, we're on the Detections tab. We can see we've got several alerts that are fired. We can see things like a user attempted to deactivate an Okta policy, someone assigned an administrative role to a user, someone attempted to deactivate an Okta network zone, and we can see the pre-assigned severities and risk scores for these rules. We can see the action that was taken. These fields are from the Okta system log itself and the user that carried out the action. We've got the option to investigate in timeline, which will open up this sidebar. We can drag and drop fields and investigate the alert in more detail. We can also click on one of the rule names, which will show us things like the query for the rule, how often the rule runs, a description for what the rule detects. And again, we can investigate the alerts for this particular rule that are fired. So as you've seen in this demo, Dorothy can help security teams test their visibility and detections for the Okta environment. It's easy to execute a test. The security team can then review their logs and the alerts in their security solution, and then they can investigate and remediate any gaps. These slides will be included in the description for the video. So all the links in these slides will be available to you. You can find Dorothy on GitHub. You can check out the project's wiki. And if you're not already an Elastic Security user, you can sign up for a free cloud trial and you can check out our free detection rules.